Hello. Um, Today we are continuing with our carboxylic acids, and today we will discuss about the reactivity of the carboxylic acid, how the carboxylic acids react with other elements or other compounds. So again, I am like going with my handwriting, so it's like a whiteboard, so it's easy to make you understand. Okay. uh, Actually, carboxylic acids can react in three ways with other elements. The first way is when the hydrogen atom of the carboxylic acid involve, and the hydrogen atom of the carboxyl group of the carboxylic acid involved. This is the first way. In the second way, when the OH hydroxyl group is replaced by an other group. And the third type is when the whole carboxyl group is involved. So there are three ways in which the carboxylic acids react. The first way is the hydrogen atom, in which hydrogen atom of the carboxyl group involved. So what happened if we take a carboxylic acid? This is the carboxylic acid, NCA. So that when we take carboxylic acid and dissolve in water, what will happen that it will give us proton. How it will give us proton? Now this move here, and it will give negative charge to oxygen and positive charge to hydrogen. So it will be a proton, and there will be a carboxylate ion. So when the carboxylic acids react with bases, and bases, most common bases, NaOH and KOH, what will happen? If I take a carboxylic acid here and I take a base, so it will replace the hydrogen atom with the sodium, and it will give me a salt, CH3COONA. You can see that it is replaced by Na, and it will give me water also. Second, carbonates and bicarbonates. If carboxylic acid reacts with carbonate and bicarbonate, what it will do, it will decompose the carbonate and bicarbonate and give us the salt. Again, I take the carboxylic acid, bicarbonate, and the reaction will occur, and the hydrogen atom will be replaced by Na. So this will be a salt. Next is the reactions with the active metals. When the carboxylic acids react with active metals, for example sodium, calcium, potassium, etc., what it will do, it will again replace the hydrogen or atom of the carboxylic acids, and it will give me this salt, but with the hydrogen gas. In the reaction with the bases, it will give me carbon dioxide gas and water, but with the active metals, it will give me hydrogen gas. Now the second type of the reactions where the OH hydroxyl group is involved. The carboxylic acids contain carboxyl group. If I say what is carboxyl group, and this is this one, C and OH, as a functional group, like the carbonyl group of the aldehydes and ketones. So it is susceptible to attack by a nucleophile. So the addition of a nucleophile to the carboxyl group is always followed by displacement of OH group by some other, always followed by displacement of OH group by some other group. So producing a carboxylic, when it will replace, what will be produced? The carboxylic acid derivative. So the OH group thus can be replaced by XOR in NH2 to form what? Halides, esters, and amides. So let's take the example. First one is when it reacts with PCl5 and then SOCl2. So first, when carboxylic acids react with phosphorus pentachloride, it will give me what? It will give me this derivative of a carboxylic acid. That will be the halide, and this POCl3 and HCl. When it will react with thionyl chloride, it will give me this one, again halide in SO2 and HCl. Let's see the mechanism of this. What is happening actually, how it is happening. So this is the mechanism of a reaction where the whole OH group is involved. The first step is I will open up the formula of carboxylic acid like that, and I will take thionyl chloride, and it will give me this one, like this. Structure will be like this. This is the CH3 and O, C and O and O and S and O and Cl, and it'll give me plus H positive and plus Cl negative. This is what I get. The H positive and chloride from here will get free, and other group SOCl will get attached to the carboxylic acid. So second step, what is second step? Second step is when I take a this product CH3 and C and double bond O and again O and again S and double bond O and Cl, and I take this chlorine also here, and this will be Cl negative. Now what will happen? Let me change the color here. Okay, so now what will happen, that this chlorine, as there is a partial positive charge here and negative charge here on the oxygen, as there is a partial positive charge on carbon, what will happen, that this chlorine will go there to the carbon, attached by carbon, and as carbon already has 1, 2, 3, 4 bonds, and its capacity is only 4 bonds, to make 4 bonds, so it cannot make 5 bonds. If chlorine will be here, it will be 5 bonds. So what will happen, when chlorine come here, this bond will break and it will go like that. So what we will have in the end, let's change the color again, and what we will have now after that, we will have CH3 and C and O negative and O and S and this one and chlorine here. Now the third step, I take my product here, and that is CH3C and O negative and Cl and O and S and double bond O and Cl. Okay, what will happen now? Let's change the color again and see what's happening now. Now, this chlorine, we will separate it, so it will make like this. Now we will do like this, it will also get separated. SO2, we want to separate SO2, so it will get separated. So now it has the ability, carbon has 1.3, so this one come here. So what we will have, let's change the color again and see what we will have. We will have CH3 and C and double bond O and Cl. And that SO2 and that Cl negative. What is this? This is the acetyl chloride. That is the derivative of the carboxylic acid. Now, this Cl and this H, Cl negative, and I take there was H, this H, and it will give me HCl. So this is the mechanism where the hydroxyl group is involved. Only the hydroxyl group of carboxylic acid is involved in the reaction. You can see that here in the acetyl chloride, the OH group is replaced by the chlorine, Cl. This is how the reaction occurs. So next, the last one is the formation of esters. Last one is the formation of esters. Carboxylic acid, let's write here so we can formation of an ester. So what happened when carboxylic acid heated with alcohol in the presence of concentrated H2SO4, esters are formed. So what I need carboxylic acid, I need heat, I need alcohol, and I need what? H2SO4. That's sorry. And I need H2, what's happening here? Okay, I need H2SO4. Okay, what will happen that, now write the reaction here. Let's have our carboxylic acid, and we know the formula, and I need alcohol, C2H5OH, and then I need H2SO4, that is acidic, and then what it will give us, CH3, C double bond O, and O, and C2H5 plus H2. That is the ester and water. Let's see its mechanism, how it's going. Mechanism. There are various first step. First step is the protonation. Protonation of carboxylic acids. In what happened in the protonation, actually, let's open up the formula of carboxylic acids, and there is as you're going to do protonation. This is what will happen. It'll go like that, and it'll make the bond. It'll make the bond, and it'll be like this, double bond, and this will be a protonation, and this is next step. Once the protonation occur, next step is attack of alcohol. Attack of alcohol, and that will be like the CH3, CH2, OH, and it will be like that. I have CH3, C, and OH, and this is O double bond and H, and there will be a positive charge, there will be a partial positive charge on carbon, and I have alcohol, C2H5 and OH in the electrons. And what will happen that this electron will attack oxygen, will attack here, so it will attack to one bond less, and it'll give me a product like this. Sorry for this. Problem solved. Okay, so what will happen, I will get this one as CH, writing CH3, C, O positive, H, and I have O and H and OH. And what is missing is C2H5. After that, third step is hydrogen ion transfer. Sorry for my handwriting, but I'm trying to make the video short. So CH3, C, and what I have O and H, and O positive, and I have H and C2H5 and OH. It will give me what I as I'm saying, this is a hydrogen of a transfer of hydrogen ion, so this will go there and this will go there, and it will give me like that, CH3, C, O, O and H, and OH, the positive one, and H, and C2H5. This is the transfer of the hydrogen ion. And then the last step is the elimination of water. Elimination of water. How it will happen? Let's take our product of the last reaction. Let's remove it, and I have O, H. Open this one. So what will happen? I need a water, elimination of water. It will go there, and this will go there. This will give me water. I need final product should be the ester, and this is the ester. And as I got the hydrogen and I got the water, this is the mechanism how I can make the esters, and this is ethyl acetate. As you can see that here the OH group is involved in the formation of esters. OH group is involved. So this was the reaction of where the OH groups are involved. Next is the reactions where the whole carboxyl group is involved. Third one, where the whole carboxyl group is involved. Whole carboxyl group means this group. And carboxylic acids on reaction with lithium aluminum hydride. Lithium aluminum hydride. This one is involved if on reaction with lithium aluminum hydride, carboxylic acids will reduced to alcohols. How it is done, as we know that if we are doing reduction, we need hydrogen protons, and what I need, lithium aluminum hydride, and it will give me alcohol, CH3 CH2OH. This is alcohol with water. This is a reaction where the whole carboxyl group is involved. There is another reaction in which the whole carboxyl group is involved, is a reaction with alkanes. So when the carboxylic acids reduce, they will give me alkanes. So how they will give alkanes? Complete reduction to alkanes. And how it will happen? I have a carboxylic acid, and I need what? HI in the presence as a catalyst, red phosphorus, and it will give me alkane. Reduction will happen and it will give me alkane, water, and iodide. This is iodide. And if I balance it, I need to balance it 6 and 2 water and 3 iodide. So this is how the carboxylic acids react. The video is a little bit long because the mechanisms or reactions are involved. I try to keep my videos short because to me chemistry is like you can take it for the 15 minutes, 20 minutes, but not more than it. You need a joke to make yourself relax and then start again. So we will continue our lessons. We will continue our organic chemistry in the next video. Thank you. See you. Bye bye.